Our summary of stepper motors. A stepper motor, a unique type of DC motor, rotates in fixed steps of a certain number of degrees, 30 degrees, 15 degrees, 1.8 degrees, and so on. The rotor, the part that moves, is made of permanent magnets or iron and contains no coils and therefore has no brushes. Surrounding the rotor is the stator, which contains a series of field pole electromagnets. As the electromagnets are energized, one after the other, the rotor is pulled around in a circle. Stepper motors used in position systems are usually operated open loop, and that is without feedback sensors. The controller will step the motor so many times and expect the motor to be there. The permanent magnet PM stepper motor uses permanent magnets in the rotor. This type of motor has a detent torque, a small magnetic tug that tends to keep it in the last position stepped to, even when the power is removed. PM motors have good torque capability, but cannot take very small steps. The field coils of the PM motor can be driven in two-phase or four-phase mode. The two-phase mode requires polarity reversal. Four-phase operation does not require polarity reversal, and the timing is more straightforward. The variable reluctance VR stepper motor uses a toothed iron wheel for the rotor instead of permanent magnets. This allows VR motors to take smaller steps, but they are weaker and have no detent torque. The hybrid stepper motor combines the features of both the PM and the VR stepper motors and is the type in most common use today. Hybrid motors can take small steps, typically 1.8 degrees, and have a detent torque. The internal construction of the hybrid motor is more complicated than the PM or VR motors, but the electrical operation is just as simple. Stepper motors are driven from digital circuits that provide the desired number of stepping pulses in the correct order to the field coils. These pulses must usually be amplified with driver transistors operating as switches before being applied to the motor coils. ICs are available that can provide the proper sequencing and amplification in one chip. This brings us to the end of our series on DC stepper motors.